everyone. I'm Susan Nash, AAPG, and as usual, I'm super excited to be here. But today, more than ever, because we are talking about a topic that is just of great interest to me, and it's just so exciting to see all different kinds of progress based on needs and demands, and also funding. So today's topic is energy innovations. And we're talking about funding. So we'll start out with David Clouse, who is going to talk to us about funding for startups and what his fund does and some of the results. And then we will be talking about the result of innovation and investment, and that's Oleg Mikhailov, who will be talking to us about Xplorobot and robotics and a handheld methane sensor, which is incredibly timely. And he, in fact, was at our wonderful conference last week in Pittsburgh where we talked about orphan wells and carbon capture and stopping pollution and methane emissions, et cetera. And then finally, we'll have a wonderful presentation by Kelsey Putman Hughes of Tulsa Innovation Lab, who's talking about basically how to do piloting of innovation and innovative ventures. So it's an exciting time. And I'd just like to say that this webinar is being sponsored and supported by our Division of Environmental Geosciences. And I noticed that our president of the DEG is here. His name is Bert Vogler, and after everyone speaks, I'll ask him to say a few words. But at any rate, I want to welcome everyone, and I'd like to invite David to share his screen, and welcome.
Excellent. Thank you, Susan.
You're welcome.
Make sure I'm sharing here. Okay, let me know when that's good to go.
It's trying.
I should have restarted my computer and given it full power this morning.
Here we go.
Excellent. Welcome, everybody. So my name is Dave Clouse. I'm a newer resident to those of you who are here in Tulsa, and I'm an ex-resident of those of you who are sitting in Houston. I spent my career at BP. Worked in their technology team and their biofuels team and their wind team and their solar team, and ended up in their venture capital team, where we focused on investing in innovation for the operations of BP. We talked about investing in things that helped their core business perform better. We found new ways to kind of expand those core businesses into tangential businesses and innovation that could kind of expand the core that we did, and we invested in brand new things that could really kind of change the world and then the company over decades to come. I got the opportunity last year to come up to Tulsa and run this early stage fund, which I was really excited about, not only because it had kind of this geographic focus to it, but I got to work at the earliest stages with new founding companies, which I'm very passionate about. But it also kind of gave me this ability to work with the same group of corporates and this understanding of how to deploy technology, how to talk to the operational teams of these organizations and find out what their pain points were, so that we could go and source the innovations that would solve them for them, that we could bring those solutions to market and interact with the corporations who are going to be the paying customers of this. And so that's kind of what we built. So EIC Rose Rock is the fund. It's a $50 million early stage energy tech venture capital fund. And we're investing in high potential companies and founders who have technologies that can really kind of change and are of strategic interest and can change the futures of our corporate partners. We invest in seed and early stage companies. So what that means is kind of from founders with one or two people who are just starting out, really kind of building the initial base of the business and kind of proofs of concept and minimum viable products and kind of those first proof of concepts that we're going to take out to market, up through kind of early stage adoption. Maybe you have a couple of POCs out there, a couple of pilots that are working with those corporate partners. We kind of help them build teams around them. Sometimes it's a technologist that comes out of a university who's doing research. It might be a professor who's been, a tenured professor who's never built a business, and we can take some of that R&D and help them kind of protect that through IP filings, and then bring that out and help them find business, or help them find customers, surround them with the kind of business people who can help scale up that idea and that service over time. And we've got the kind of, the market and the technology, the commercialization resources to help really accelerate that. And we do that through these partners that we've put together. Given, this is a Tulsa focus, we have partnerships with the 4 largest energy corporations in Oklahoma. So Devon Energy in Oklahoma City, Williams, ONEOK, and Helmerich and Payne, all here in Tulsa. So we work closely with their innovation teams and their operations team, again, identifying what those problems are, and then going out and sourcing solutions. So we see hundreds of deals every single month. People are constantly sending in pitch decks to us, either through the website, through me going out to different innovation events, trying to find ideas that match up with these problem statements, and then helping to really kind of bridge that gap. And I call myself a translator in a lot of ways. It's translating the different languages that a founder would speak, or an innovative startup company would speak, versus a large scale corporation that has tens of thousands or hundreds of thousands of employees. They work in completely different ways, and they think different, and their incentives are different. The incentivization structures of the people are different. So you have to understand how that all kind of can come together. But at the end of the day, it really is matchmaking, and it's a match that needs to happen. You have innovators who have brilliant ideas, but need capital and access to customers and more expertise to take those out to market and scale those up to change the world. And you have corporations that have money and they have revenues, but they don't always have the best innovation. They can kind of become stale in the way that they do operations, and they know they need to continue to innovate to thrive and survive over the long term. So being able to match these two groups up in a way that's beneficial to both parties, they can. A corporation can completely take over and smother a startup company if you don't do it right, and a startup company can bring chaos to an organization if you don't do it right. So helping them blend, and again, translating, helping them speak those languages is important. We make small investments. We're early stage investors. We make initial investments in the kind of $500,000 to $1.5 million range, and then anywhere over $2 to $3 million over the lifetime of that investment. So we'll maybe put some startup capital in early, and then build from there as the company progresses. And a lot of them don't progress. In venture capital, half the companies that you invest in end up failing. It's just the way that we work. And the times that you get it right, there's massive returns on the end, and that makes up for the half of them that have failed and went to zero. We built a portfolio over the last 18 months. You can see them across the bottom, and we can dive more into those. All the way from hydrogen to lithium extraction, desktop, mobile, mass spectrometry, direct ocean capture of carbon dioxide, domestic critical minerals production. Phoenix Tailings is the first and only company in the United States right now to be producing rare earths, dysprosium, and neodymium, and are scaling that up to nickel production. Salient Predictions is an advanced weather prediction center that helps companies understand what they would do in their operation centers if they could have a better idea of what the weather would be in kind of 2 weeks to 2 months. We have advanced DRA, drag reducing agents for midstream customers. Two of our corporate partners are big midstream companies. And then our most recent investment that we made just a couple weeks ago is a new AI-enabled job site safety platform called Safety Radar. So we do a little bit of software, we do hardware, kind of everything in between. Again, each one of these companies has a tie back to a problem statement of one of our corporate partners. We've got co-investments with those corporate partners, and we've got deployments with all of them. So really the kind of engagement function happens in this early stage. We call it our Fusion program, which is this innovation advisory function where we go and we spend a lot of time with these innovation teams and with the operations teams of our corporate partners, really kind of identifying those problem statements and doing sector deep dives into areas that are of importance to them. So one of the great examples of that last year. We did a sector deep dive into geothermal for Helmerich and Payne and Devon Energy. And out of that, you really kind of, you think about geothermal, there's a lot of geothermal companies, that kind of the brand name ones that you might have seen. But there's also, kind of from the operators, there's also a lot of different portions of the geothermal segment that you can kind of dive into and understand, where that corporation might bring a lot of value or expertise or be able to provide some kind of outsized help to really drive a company forward. So you're not just kind of looking at those brand names, you're looking at all the little subsectors of that industry and where you can find value and where you can provide value back to give yourself an edge in that investment. And then from there, we really kind of find those companies that really match the profile of what we're looking for. And we have this bridge program here. It's an incubator and accelerator program here in Tulsa to really kind of wrap the business formation services around those early stage founders and help them through that first year of building that company up. That can be, helping them find people. We have, services to match them up with the correct skill sets. We do a lot of work with the actual corporate partners. So the Safety Radar went through this program last year, and some of the best conversations they were able to have were with the safety teams and the procurement teams of our corporate partners, understanding what they need, what they want, so that they knew that they were developing the right product for those companies. And then after that company is kind of up and running and kind of has its legs underneath them, my Rose Rock fund then comes in and provides the investment to give them the kind of tech validation and take them up through the next stage of the company until some larger funds and companies can come in and really put more money to bear to commercially scale that company up to a large state. So again, we can really kind of leverage that early origination activity set, and help these startup companies expand and grow into corporations of their own that can be partners to our other corporate partners and large energy companies. So we look for, early stage. We want technologies that are not 10 years away. We want to have something that is kind of a couple of years to commercialization. We want technologies that have, prototypes, proof of concepts that we can kind of see and feel and touch and understand what they are and help the corporations understand that bit of it. We focus on three different areas of innovation. We call them sustainability, energy transition, digital technologies. So to us, sustainability is the realization that there will be hydrocarbons for kind of decades to come, and we need to be as sustainable and finding those hydrocarbons, extracting them, and helping customers use them in the most efficient manner, not be wasteful with them. So those include things like methane emissions reductions and produced water solutions, some carbon capture technologies, and like we talked about with the salient investment, weather resilient energy systems that can kind of live through kind of new storms and the things that are happening in the world today. There are going to be, the energy transition bucket is around the fact that there will be different portions of the economy that transition to new energies over periods of time and different time periods. So you'll see passenger vehicles, right, transitioning faster than jet planes, right? So we would make investments into more nearer term to be able to provide a return to our investors. Some focus areas that we have: geothermal, we talked about that. Renewables, storage, batteries, grid modernization, distributed energy systems, and along in this bucket comes a lot of kind of sensor controls that we can talk about in a minute. And then digital technologies to us is, again, anything digital that really touches the kind of energy industry, with a focus back on that. It's kind of a high level detail, but I don't want to run out of time, so I'm going to flip through this. And again, really the advantage that we have here is this partnership that we have with our corporations, and then with GKFF, George Kaiser Family Foundation, being the anchor investor that funds the Tulsa Innovations Lab and funds a lot of the activity sets here in Tulsa and gives us that regional Tulsa focus, where we try to invest in any technology that will help, but also then have assets at our disposal that we can encourage and financially incentivize companies to come to Tulsa itself. So I have just a few, I don't know, do I have a few minutes? I got one more minute here. So I just kind of, to me, the digital oil field, we talked about this. I went back through kind of the big changes that have taken place over the decades. And I go back to kind of the earliest examples that I saw were the kind of 2D seismic back in the 80s. That was digital oil field. This isn't something that's just new in the last kind of 10 years. We've had digital oil field back into the kind of 60s. But it was these big advancements in technology that kind of play and allow for new advancements to come forward. And really in the 80s, it was the advancement in compute power that allowed 3D seismic imaging to become economically viable. So that allows then, subsalt viewing of seismic, which really, I was thinking about that being here in Tulsa. That was really what accelerated the growth of the Gulf of Mexico and corporations moving to Houston from Tulsa. So that advancement really kind of hurt the Tulsa economy at that point in time, and was like the beginning of the end of that for us, right? So I was kind of reflecting on that this morning. So we're hoping that we can find new advancements to maybe switch that back and bring people back to Tulsa. In the 90s, it was the horizontal drilling started to expand. In the 2000s, it was life of field seismic and 4D seismic that really kind of improved. And in those 2000s, you got wireless technology that really started to come to the forefront and allowed for digital sensors and things that were, you could kind of have centralized controls of these vast sensors out in the wells. In the 2010s, it was massive data that was now being generated by all of the sensors, and how do we work with that and make sense of that and drive information out of that, the transmission then to cloud services and data centers and things like that. The automation potential kind of got there, and now what we're seeing in the kind of 2020s is this advancement still in compute power and the advent of AI and machine learning and our capacity to be able to utilize that to a higher extent. And so back with sensors, it's around these old manual gauges that are now becoming digital gauges. We even saw a technology that was old manual gauge that was being digitized by a camera that could read the actual sensor on it and tell you what pressure was at different points in time. A lot of this is being used for predictive maintenance, for digital twinning. But data transmission is kind of the next step that we're looking at. And can you actually take the data from the field to some centralized location to process it, transmit it, and understand and gain learnings from that? Or are you taking the compute power back to the actual data, the oil field itself, with edge computing and then edge AI that can kind of process all of that data right on site and bring you readings and start to interact with the different smart sensors that are there to create opportunities for truly autonomous operations. So those are all the kind of technologies we're looking at. I had one more slide of companies that are in this kind of space, but I don't want to take up any more time here, so I'm going to pass it over now to, I believe, Oleg, correct?
Yes, thank you. Oh, this is great. And we'll have time for some questions and answers later. So I'd like to invite Oleg to share his screen.
Excellent.
You might have to stop sharing.
Oh, sorry.
Little detail.
Hit the wrong escape. Perfect. There we go.
There we go.
That's an excellent transition. So I'm Oleg Mikhailov. I'm the CEO and co-founder of Xplorobot, technology company. We're primarily focused on computer vision and AI, but we're bringing the software into the oil field operations by enabling either sensor packages that are driven by our algorithms that are deployed by people, or that we've deployed sensors on autonomous robots on offshore platforms, FPSOs, big gas plants, etc. Our focus now is on methane, and specifically, Susan invited me to talk about the application of our technology to orphan wells. So I'm going to share my screen real quick. But actually, in terms of my background, because it may be useful, I spent my entire career in oil and gas industry. Started in technology with a PhD from MIT in geophysics, and worked in the seismic imaging team at Chevron, but then moved into commercial roles and then into operations roles, and ended up running large onshore and offshore operations, ran a large gas field offshore Gulf of Thailand. It was the area operations manager for Gulf of Mexico Shelf for Chevron, and then moved to British Petroleum's joint venture in Russia, where I was the head of Western Siberia division, which operated about 30,000 wells and produced 1 million barrel of oil equivalent a day. So the solutions that we're bringing to oil and gas are super high technology, yet they're built to be very pragmatic, to be deployable by regular individuals. So in fact, I'm wearing FR clothing right now because I just drove back to Houston from a pilot at a very large midstream company where we're deploying our sensors to identify methane leaks. And we're using a camera that has a bill of material of $10,000 and can be deployed by any operator without any special training, because all the interfaces on the screen, literally with a start and stop button. We're using it to do the methane inspections at the component level that are typically done by the infrared OGI cameras. So we're replacing $10,000, $120,000 camera operated by special people with a $10,000 camera operated by anybody. Because in our belief is that there are so many emission sources out there that without enabling every operator, every pumper to be able to see the emissions and address them, I don't think we're going to solve the challenge. I mean, literally within 45 minutes at the site, we identified about 12 different emission points, and I'm not allowed to say what it ends up to, but it was a substantial amount. But today we'll talk orphan wells. So I'll share my presentation. And the important thing in orphan wells is that the United States government has the intent of eliminating emissions first from the orphan wells by plugging them, and then is offering a voluntary program for marginal wells where the government will provide funds to plug your well if it's creating enormous emissions that can be avoided. Now, to address this problem at scale, and there are various estimations of how many orphaned wells are there, like the estimations range from 300,000 to 4 million, and the truth is somewhere in between. But you need to really quickly identify which wells emit methane, which do not, in order to plug the ones that will generate the most impact for the environment. Now, it's easier said than done, because if you need to evaluate methane emissions out of 1 million wells, you actually need to often hack through the bush with a machete to reach this well. And then if you have super expensive hardware, or you're carrying a pretty significant kit to do the methane detection and quantification, then you're making it not only logistically intangible, but extremely complex and expensive. So what we came up with is a solution that, as I showed you, is handheld. Simple device, simple graphic user interface, and it has the following characteristics. Number one, it meets the Department of Interior 1 gram per hour sensitivity requirement. We've demonstrated it numerous times in the field, and I just submitted a report of controlled release experiments to the Lawrence Berkeley Laboratory, where we yet again demonstrated the ability to detect 1 gram per hour in the controlled conditions. But we also have numerous experiments in the field with operators, with orphaned wells, where we detect sub 1 gram per hour. The data collection is extremely rapid. So we carry a 4.5-pound sensor in a shoulder bag, and it takes 3 minutes to scan a well. That's it. You don't need to rig up things. You don't need to set up complex infrastructure. And we give you both the detection of the emissions, and we give you an estimate of the flow rate. And I will talk about how we estimate the flow rate from scanning the equipment. From the oil and gas perspective, the equipment we provide is compliant with Subpart W, which is the general reporting of greenhouse gas emissions. The United States is enacting new regulations for the oil and gas, Quote OB, Quote OC. And on March 8th, this regulation will be published in the Federal Register, and within 60 days of the publication, the technology portal will be opened, and we will submit our application to EPA. We're submitting our application to the Colorado Department of Public Health and Environment this week. As I mentioned to you, this tool can be deployed by any inspector, any operator. The importance of it is as follows. The optical gas imaging camera, the infrared optical gas imaging camera that costs $120,000, that's not only the insult, here's the injury. You have to have a highly trained, specialized inspector. And EPA itself quotes $195 per hour for an OGI inspection cost. I was told 280 3 weeks ago because the demand for these inspectors is going to the roof. So we're not only replacing a $120,000 device with a $10,000 device, we're replacing a $195 an hour person with your regular pumper, $25 an hour. And by the way, he was going to the path anyways. So he just grabbed the device, scanned the well or the separator, brought it back, Xplorobot takes care of it. So we are disrupting both the hardware and the high cost labor market with software. That's really what we are. So don't take my word for it. We participated in blind experiments at Methane Technology Evaluation Center, achieved the best results in class, 98% true positive, 2% false positive. So at the moment, and I'm sure half a year from now, somebody's going to come up with something better unless we continue to evolve. But at the moment, we're the most accurate technology in the market. And we're fully digital, and I'll show you the results. So quickly about the sensor, it's powered by the basically a tunable diode laser absorption spectroscopy sensor. The sensor that emits a laser at the wavelength that is absorbed by methane molecules receives the signal and can figure out how much loss is due to methane. So it calculates the concentration of methane along the path. It has the wind sensor, which is critical to defining the flow rate, and we'll talk about it later, and a few other sensors. So Xplorobot has we submitted a provisional patent on this, and we are submitting a US patent on this device next week. As I mentioned to you, we are officially the most accurate technology in the market, and we tremendously thank the Methane Emissions Technology Evaluation Center for their hospitality and help in kind of guiding us in how we can improve our technology. We are officially matching the performance of infrared OGI cameras, and not just infrared OGI cameras. So METEC performed blind tests, and they separate the performance of people just novices, so LDAR certified inspectors who had little experience and high experience. So our device matches the performance of infrared OGI camera in the hands of the most experienced LDAR inspectors. And ours was, these results were generated by 4 25-year-olds with degrees in mathematics, architecture, chemistry, and engineering who never worked in oil and gas companies, never were certified as LDAR. They joined Xplorobot from school and enjoying it. So we have the performance that meets the standards of the United States EPA. And as I mentioned to you, in numerous field conditions, we demonstrate even less than 1 gram per hour. This is 0.3 gram per hour. The outcome of our inspection is always a digital twin of the well or a separator or a facility that we inspect. Why is it important? These are our results that we're accumulating today. We worked on 3 continents with over 20 companies, but focusing on orphan wells, I'm going to talk about Osage Nation, the project that we're initiating with Lawrence Berkeley Lab with the funding from Department of Energy, and we're tremendously grateful to them for their partnership. And for each of this dot on the map, this is an individual wells that was scanned. So I'll start with showing you the scan of a well that has the emission. So you do have the emission, but what we give you actually 2 things. One is the actual distribution of methane concentration on the well. So you can see that not only this flange is leaking, but it also the methane concentration is actually is here. Less important for orphan wells, extremely important for oil and gas. So we specify the emissions not just from a flange. We're often pointing out a specific bolt on the flange, so the mitigation can be provided immediately. We also provide the visualization of methane emissions in real time, which is another requirement of the United States EPA to be called an optical gas imaging. That's why our device is called Xplorobot Laser OGI because it is providing optical gas imaging, which is visualization of methane emission, otherwise not visible to the naked eye. So this is the story of something that is emitting. But what is equally important is having a digital record of zero emissions. Whether it's, oh, this is not looking good, but pick up another one. Pick up another. So we have the color scheme of the model needed to be balanced in order to show it properly. So the digital record of zero emissions provides you with an auditable trail that at the time you performed the emission, there was actually zero recorded. It's important for orphan wells because if you have people going through and saying, I have scanned 100 wells and I didn't find emissions on 85, if that well is in the bush, you're relying on the word of that person. And if you're sending people at mass, you will be sending hourly workers, and having an actual digital trail for what they have inspected is important. So here's an example of a well where, again, a full scan was performed, and we have projected every individual methane measurement, which our device takes about 10 times a second, onto this digital twin of the well. So I actually have a digital record that neither this connection, nor this connection, nor that connection is emitting, and there's nothing emitting around the rim of the orphan well. So we're creating digital records of zero emissions for people to utilize in actual certification that, okay, the well was not emitting. To kind of provide entertainment for you, I'll give you some examples of what the current infrared OGI cameras cannot do, which is we were working at this gas plant, and just while walking from one side to the next, William said, hey, there's something emitting here from the ground. I called the operator, and he said, there's nothing there. You're dreaming. I said, hold on a second. Super accurate tool. Let's look at it from the other side. No, here it is. It's like, damn it, there's absolutely nothing there. He digs out with his foot. Out comes the tubing. And of course, the tubing under sharp gravel, somebody stepped on it and punctured it, right? So fun stuff about how technology enables you to detect methane emissions. When I presented at the Orphan Wells Conference in Pittsburgh, and I would like to thank again Susan for invitation, there was a question about how accurate is your device. So we are working continuously with the various controlled rate experiments, and we're also carrying quantification devices such as high flow to the field to accumulate the data. And we're getting to be pretty good. This is a result of controlled experiment at the Alberta Methane Emissions Program. Now, why are we able to detect the concentration? Well, so my co-founder, Richard Clark, is a former chief geophysicist for TGS, the largest seismic contractor in the world, and I worked in seismic imaging myself. So just to give you an idea, what we basically are doing is we're scanning the well from all directions several times at different angles. And you can do a poor man's tomography on it. And if you also measure the wind speed, you combine it into defining the shape of the plume from where you can detect, back calculate the emissions rate. So this is what we used to do before the first cup of coffee when we worked in seismic imaging. We're now applying to the methane emissions rate estimation. Hence, this is why we needed to have a laser, because the laser gives us pretty sharp, pretty narrow aperture, and we can actually accumulate data points such that we can calculate the flow rate. So that's our kind of advantage in the field. We are, we've been in the market with this device. This device first was integrated in May of last year. So we're less than a year, but we're already working with ExxonMobil, with some large gas producers in the United States. We working in Germany, in UK, went to Australia, but decided that the flights are too long. So we're going to expand in the US as a first step and then start traveling. If you have any questions, please send me a note. And I'd be happy to discuss the technology. If any of the listeners is actually doing any work in the orphan well programs, or if you're just running some methane emissions detection programs, be it for oil and gas, be it for landfills, be it for operating plants, for power plants, we would love to talk to you. So thank you so much for your attention. And again, thank you, Susan, for inviting us.
No, thank you. I just think this is such a breakthrough, and just the fact that it's handheld and operator friendly is huge. I also am amazed that you selected the Osage County example. So we're really Tulsa centric. It's great. Anyway.
Oh, we really appreciate the hospitality. And again, I just want to say that we're by no means geniuses, right? Think about 3D seismic survey with a constant speed of sound. Tomography is trivial, right?
Interesting point. Yeah, that's true.
So
Well,
we're basically bringing what we did in seismic into the world of methane emissions management.
that's amazing. Well, and so that's a great segue too to Kelsey Putman Hughes, who's going to talk about how to pilot and to get new technology adopted and disseminated.
Absolutely. Thank you both, Dave, Oleg, and Susan, for putting this all together and collaborating so well. So as an introduction, my name is Kelsey Putman Hughes. I'm the Director of Energy Tech for Tulsa Innovation Labs. We are an economic development kind of focused organization that is funded, as Dave briefly mentioned earlier, from the George Kaiser Family Foundation. And so we deal mainly with economic development related problems through the lenses of 4 tech clusters here in Tulsa. And so I lead the energy tech portfolio of initiatives and programs. And as a bit of context, I'm a geologist myself. I've lived and worked here in Tulsa in the energy sector for close to 15 years now, and now find myself in this kind of new flavor of economic development and energy and how these things all really play together. So I'm going to share my screen now. Okay, perfect. So I'm going to walk through the latest kind of initiative that we're working on now. And it's mainly how do we bring everyone together within the energy sector, and how do we basically unlock all of the potential that we have essentially in our backyard. So right now we're in this phase of needing to really essentially identify what the common ground needs are for the energy sector here, specifically within the lens, since I do have a regional focus area and mandate. How do we catalyze all and bring everyone together within not only Oklahoma, but then very specifically within the northeast region of Oklahoma? So really in this era that we're really defining this amazing advancements, as Oleg was describing with his specific technologies, we're having so much rapid technological advancements within our sector, but we're also facing a lot of these kind of unprecedented challenges of how do we mitigate some of the problems that we've experienced in the past within our 100+ year long legacy as an industry. And then how do we address those problems and then not bring those same problems into the future as we are advancing these new techs and new energy resources? So how can we sustain and basically find efficiencies of these existing legacy energy problem sets, and then kind of grow and evolve and kind of meet the global energy needs of the future while unlocking some of these place-based resources and provide future pathways for our energy workforce? So I'm advocating that we need to be taking kind of a regional solutions approach here. And looking at Oklahoma specifically, we're an incredibly energy diverse state. I know I'm probably preaching to the choir here in this case. Of course, Tulsa has long been identified as the oil and gas capital of the world, where most of that information, as Dave mentioned earlier, has actually been migrating out of state. So we're actually, unfortunately, not only facing a brain drain of our workforce and kind of losing our energy workers to other basins and then other resources, we're also, unfortunately, retracting and kind of losing some of those energy corporates that had been focused in legacy energy here in Oklahoma. So the companies that we have here now, how do we make sure we can aid them in their efficiencies and deployment of new technologies? And how do we catalyze and bring along these other energy resources, and are there shared things that everyone can play with and utilize? So just as an example, Oklahoma is very dynamic in the sense that we're, third in the nation for wind energy production. And we're sixth in the nation for solar energy potential generation. And of course, fifth in the nation, I believe, for natural gas exports. So not keeping in mind that these are all very, very much geosphere focused. This is very important for geoscientists. How we can maximize what is happening on 1 acre within Oklahoma. You could be generating a tremendous amount of energy just based on wind, solar, natural gas, oil production, geothermal, and so forth. It's frankly almost overwhelming, but how do we harness these unique combinations of in-place resources and really propel Oklahoma to the forefront of this kind of really essentially our second industrial revolution? So we stand at this really unique intersection of rich energy resources, our critical infrastructure that it is already in place, and of course all of these legacy energy businesses. So with the energy corridor basically being centrally focused here in Oklahoma, we really offer kind of an unparalleled opportunity for innovation and growth within that energy sector. So what it all really boils down to is that Oklahoma makes, creates, and really moves the energy industry for the nation. Maybe a little bit boastful in really essentially our importance here, but I think because we have so much potential and we have so much access to naturally occurring in situ energy resources and that kind of confluence between our infrastructure systems as well as the manufacturing prowess of our area, that lends itself very well to our region being able to pilot innovative technologies right here in our backyard. So that is leading to this effort that Susan was alluding to, is the OK Pivot project, which is the workflow I'm working on now, which stands for Piloting Innovative Ventures for Oklahoma Energy Technologies, and how we distill that down into a report. So we're going to be highlighting this vast potential of Oklahoma's energy landscape and providing a comprehensive roadmap for pilot and demonstration ready technologies. So we're going to be doing that by basically aiding, and accelerating the adoption of energy tech solutions, creating these high quality jobs that are associated with implementation of that work, and then strengthening our supply chains within our region. So we're going to, the OK Pivot report seeks to provide a comprehensive analysis of the Oklahoma energy landscape. And we will be doing that by addressing it through kind of this following lens. So why is this necessary in the first place? Well, because we have so much potential here, how do we unlock all of this access to information in our existing place-based resources? And so Oklahoma needs to understand that really essentially the distinctive local to regional challenges faced by the energy industry and what opportunities for innovative energy companies to essentially address these challenges. So as Oleg was mentioning earlier, that we have so many in-place orphan wells, there's a very unique challenge there. And now, while what might be perceived essentially as like a problematic workflow is actually an opportunity for a company to come in, pilot their technologies, and solve that problem. So who this report and workflow benefits is the existing energy ecosystem and our stakeholders here in Oklahoma. So this is essentially for everyone and to benefit all. And what it is really how we look at our assets in our backyard, by assessing our critical infrastructure that supports both legacy and renewable energy resources, as well as provide a look back at an in-depth analysis of energy generating resource access and the impact to the local, regional, and national energy sector. And so we're going to be addressing kind of the where of this is where the assets are actually located. So of course, being a geologist, speaking to other geoscientists and map-minded people, this is an opportunity for us to basically be assembling all of those layer files of all of our pipelines, where actually maybe the solar predictive index is kind of looking, and are there any thoroughfares in the state that we need to be aware of? Are there any special designations that we could be potentially taking advantage of as an incentive for business attraction? So we're also going to be assessing and doing a kind of stakeholder market map. Who are the players within the energy ecosystem in our 5 regions in Oklahoma, and what do they work in? We're in this very, very dynamic point in time right now where so many of our energy companies are diversifying their portfolios. And we also just need to critically understand where the market gaps are. And then that is an opportunity for us to be bringing in companies to address those market needs, and to really cement Oklahoma as a dynamic place to pilot new technologies and grow those businesses. So when is this happening? Yesterday. We need to do this right now. So actively, we're working towards building out our advisory committees right now to help aid in the content generation and assembly of this information. There's wonderful workflows right now that we're exploring, and in partnerships with the state of Oklahoma through the Commerce Department, as well as through OCAS, some of our more specific technology-driven agencies. And this is an opportunity for us to make really critical investments in the state, and to make sure that we're all talking the same language and we're all moving forward together. So how we're doing this is through regional collaboration and involvement of all stakeholder groups that really involve all the technologists, all the companies that have the new tech and just need access and people to talk to so it can get implemented. So this has been an opportunity for us to build out actual programs, and the opportunities that we have for impact and outcomes are really looking at how we can identify and categorize the suite of energy industry assets available in Oklahoma and identify them by region. And this will ultimately raise Oklahoma's profile as the preferred test bed for new energy innovations and provide clear pathways for local, national, and international energy companies to site and validate their pilot and demonstration projects right here in Oklahoma. Ultimately, the desired outcome is to grow new energy generating resource sectors in Oklahoma, drive efficiencies with our existing legacy energy companies and workforce, and to create new jobs. If any of you are like me and have maybe worked in the Tulsa oil and gas space, your resume is probably pretty peppered with companies that have either gone bankrupt, have divested and left the state entirely. And that this is now an opportunity to make sure that there is a place for our energy workforce of the future, inclusive of those of us in it today, of what we can do now to have lasting impact and basically continue to grow and sustain Oklahoma's energy industry. So as just a quick look assessment of the project itself, we're really focusing in on components of this energy ecosystem that is really driving kind of this innovation pipeline, providing entrepreneurial support, business support to ultimately grow the energy ecosystem through this targeted approach. So we're doing this from the capacity of talking and speaking out to those of you that work in the energy industry and kind of aligned tech clusters like transportation and within manufacturing as well. Get involved. The time to be involved and to have your voice heard is right now. So we're making sure that we're engaging with as many stakeholder groups as possible, from community organizations to entrepreneurs, our business and tech communities, non-government entities, all the way to municipal and federal government entities as well. And of course, our academic and research and development partners. And I want to emphasize this again and again that this is a resource agnostic approach, that this is purely collaborative and is not one that is, driven by kind of advocating one resource over another. And so there are 3 different pathways that we're suggesting that stakeholders can be involved in, both in the advisory capacity, how the structure of this report actually is put together and structured, and how we can communicate it out. Being a geologist, I of course would love to see this be generated into probably a web portal that we can actually use for mapping purposes. Be a content collaborator, or also work with us as an implementer, that we can, if you are a company that has a physical asset and would like to host a technology, be part of this implementation network and actually be a host for some of these pilot and demonstration projects. So we do have the following short list of organizations here that are serving in these different capacities. Of course, this is a partial list. There are plenty more of this where we can move to in the future, and we're currently exploring. And so I would say, if there's anything that I can address and you want to talk offline, please go ahead, scan the QR code. That'll provide all my contact information right on your phone now, or just send me an email. So I will turn the presentation back over to Susan, and thank you for your attention.
Thank you. That was great. So just really appreciate it. And we do have some time for questions. I've noticed that we have some questions and answers in the Q&A box, and 2 have been answered. So they're interesting about, well, Oleg, I'll let you kind of summarize the 2 questions that you've responded to.
Yeah, I'm sorry, just responding live. There are questions about, there's a question about how our device compared to some other handheld device. The important issue is not the device. Device is a combination of commodity components. It is the software inside the device that is valuable. So there's a question about the sensitivity detection. I talked about 1 gram per hour. But what I just would like to emphasize, our solution is not a detection solution. Because we provide a fully digital infrastructure for data collection in the field, transfer and analysis, linked to corporate databases, reporting, tracking the emission sources, and then creating the zero emissions record to validate that the repairs was complete. We're providing the entire digital infrastructure for methane emissions management, where the tool is only the starting point. In fact, for a software company to order a screwdriver and then look up on Wikipedia which end to hold, it was a painful experience. We just met with one of the providers of hardware and asked them, would you like to integrate a device for us? And they said, we're not stupid enough to give you dumb hardware for you, Oleg, to make money with software. Okay, we said, damn it, we'll buy a screwdriver. Again, ours is a digital service that only initiates with the sensor, the emission reporting, analytics, follow-up for the repairs, zero emission certification, everything on the dashboard with all the analytics that are on top of the database is what really is most valuable to the customer.
That's great. So I'm looking at some of the open questions. And so Jim Tucker is making an interesting comment about managing large numerical geographical data sets. Jim, do you want to elaborate a bit? You can turn on your microphone.
Oh, nothing in particular. It's just when we think back about how we've been managing some of these large data sets, it all started, in my experience, with the Landsat geographically tagged data sets and the sensors there. And now we're doing so much more, all the way to our mobile phone traffic reports that are geographically based. So interesting. Thanks.
It really is. And that leads me to ask a question of both Kelsey and David about the role of analytics in evaluating and ranking the technologies and the opportunities.
Absolutely. I can speak to that briefly. I think that the opportunity that we have here with being able to take some of this hard data that we have that is generated from, I mean, we're talking about everything from like, let's just say downhole, temperature data, that can be utilized to help inform maybe, geothermal prospectivity across a given region. And like, I think it allows us to maybe think of like how we have maybe traditionally thought of, prospecting. We can basically be prospecting in this sense for what the problems are and then help inform. We know that there's solution sets out here, but it can actually provide a very a critical understanding of that intersection of the different types of problem sets. And of course, the most of them in this case, since we're dealing with the built environment and within kind of the geosphere, they're all going to be land tied. So how that relates back to what our critical infrastructure assets are in place, it should help us inform what is needed in the future and then how we can advance that. So we can really, instead of maybe, treating a pothole that really isn't a problem, maybe we need to actually replace the bridge. So I think that really leads to and speaks to the effort that I'm working on for the pivot report.
Oh, that's really interesting. And David, kind of tying it to some of the technologies that you're working with, do you see a role for analytics?
I think it's key to what that is. What I would like to see is not only the kind of the data collection and then the analytics that are happened, but then that next step, which traditionally would be kind of a human's role of analyzing that kind of outcome of the analytics and making a decision based on it. I want to see that sensor, that tool functionality to be able to analyze and predict what comes next, right? Do the thing that the human should be doing. And maybe you gain trust over time by just referencing what that action, believe that action should be, and then that person can accept it and get to a point where that person is accepting it all the time and just lets the thing work on its own. And that way you've then taken out 80% of the kind of issues that a human would normally deal with that are easy issues that are just kind of functionally can put together with that analytics package, the AI package, and free up the time for that person to go and focus on some really hard problems that aren't able to be solved with kind of traditional algorithms and AI and ML. So to me, it's analytics is just the table stakes of it. It's moving on beyond that.
Oh, yeah, that makes a lot of sense, especially if you look at the issue of risk and risk management, the potential outcomes, and then just kind of even doing a heat map of like what are the different scenarios that could happen and the likelihood, and then sort of using that to analyze it. So Mason Young has a question I think that applies to you. So generally, what are the terms for the seed investment and Series A investment?
I mean, they can terms and you mean valuation, things like that, or
I guess maybe is it a loan or is it a grant or?
okay, so yeah, so our the initial bridge program, they provide $100,000 of non-dilutive, so that would be a grant. You don't have to pay it back. It's about getting that company set up and funded. And then the funds that we provide are equity. So we buy equity stakes in the company. There are other venture teams that do debt. Ours is specifically focused on equity. So we would buy preferred shares in the company and set that company up so that upon a sale, not only the founder, but all the investors would get some type of monetary reward back.
That makes sense. So you basically exactly. So you're looking for growth.
Yeah,
And
we're looking for growth and we're looking for alignment again, right, with our corporate partners. It's easy
Mhm.
for Devin to push something off for a couple of months or a couple of quarters, right? But a couple of months and a couple of quarters is all the money that a founder might have, right? They only have 6 months to get this done, and then they run out of money, and then they're done. So you have to create that alignment, and having them have an ownership stake in that startup company brings a different incentive structure to a large corporation, where they're willing to kind of maybe take some actions a little bit faster, be a little more agile with the decision making processes they have. So it's not a function of you need to have that. It's a function of finding the right alignment to drive the outcome that you're looking for.
that's interesting. Excellent. Well, we're pretty much out of time, but I think that we'll do one last question for Oleg, and that was answered as I was looking at it. It disappeared, but it basically has to do with how the unit, what is the unit's capability for measuring in soil methane?
So I answered the question, but I'll elaborate just a little bit. So we measure concentration. Therefore, if the seep from the soil provides a certain level of detectable concentration, we will pick it up. So most likely, we're not going to be detecting methane due to decomposing organic material in the soil. But we worked in landfills where the wells that produce methane then pipe them into PVC piping that is really buried shallow, maybe a meter. And sometimes the bulldozer runs over and cracks these pipes. So we can see, we have examples of a kind of extended concentrations that are aligned, in the direction of pipes. So again, if somebody has a specific application in mind, please contact us and we would be happy to discuss.
Perfect. Well, that pretty much wraps up our webinar today. I would just want to remind everyone that you will get an email from me with a copy of or a link to the recording. And I just wanted to see if Bert Vogler is still here, just to have him say hello just briefly. And as he turns on his microphone, if he's here, want to thank again Oleg and David and Kelsey for fantastic presentations, and want to thank the Division of Environmental Geoscientists for and Bert Vogler, our president, for sponsoring this, and also all the APG members. And I want to encourage you to join and renew. So thank you.
Thanks very much, Susan. I appreciate the plug for DEG. And yes, we are eager for participation in the division. Thank you to all three of our speakers. Great and interesting presentations. I hope everyone has a great rest of their day.
Thank you. So that worked out perfectly. So goodbye, everyone, and we'll be in touch.
Thank you, Susan.
Thank you, Suzanne.
You're quite welcome.